Hello everybody, this is Dr. Barnett, and in this video I'm going to talk about how do you go about reading a data model. Essentially we use data models in industry, in development to figure out what the structure of our data is, but a data model is also a very good tool if you happen to be a manager and you need to have some sort of idea about what kind of data that you have access to for your decision making. So what I'm going to cover here is how you go about reading them so that you can understand a data model fragment if you get one. What we're not going to cover is we're not going to necessarily go into all the nitty-gritty details of how to build one. Okay, so let's get going. So what is a data model? Really, it's a conceptual view of the data that's used by an application. This can be a sales order type application. That's a example application that students in some of my classes are using. It could be a personnel application, order processing, whatever. But essentially, it's the conceptual view of the data for that application. It's conceptual in that it's an abstract picture of the data. It's not physical. There's no implementation detail. It's just really a graphic of what's there. And again, mainly we use it for communicating with the organization and with other developers in terms of what data is used by the application. And for the case where you're a manager and you have access to some amount of data so that you can do decision support type operations, you could use this to figure out what's available to you. So things that it shows the basic data elements that are available to you, entities, attributes, and how those are connected. It shows you how things are organized. So all the facts that are important are essentially organized into entities. And then these entities are related together. This is how we can store specific data in one entity or in one table and then connect it later. So we want to make sure that if we need to get data out of one table and combine it with data for another, we want to make sure that there's some sort of connection there. We can also show some of the rules about how we do business. Depending upon how verbose our data model is, we could show things like how many times something is connected to another, how few times something is connected to another, or whether or not it's required to be connected to exist or not. That's a little more in the weeds than what we're going to cover in this particular video, but those are things that you can definitely show with one of these data models. So here's an example of a very small fragment of a data model, and in the green cube is a specific entity. And if you're a data modeling aficionado, some people might call them entity types. It really doesn't matter. It's a matter of philosophy, and again, that's much more for professional developers and PhDs like myself to get into. Now, there's multiple syntax for drawing these models. The one that I'm going to use in this particular video comes out of Microsoft Access. This might also be the modeling syntax that's used in other Microsoft database products like SQL Server. I'm not exactly sure if SQL Server uses this, but I know Access does. So, and most people can get a hold of Access, and while it's not the most fantastic database product in the world, it's better than a spreadsheet. So if that's what you have, this is the modeling notation. The students that are working on projects in my class, this is the particular picture of the data that they have at this time. So that's what I'm going to run with. So each one of the boxes in a data model represents an entity, aka entity type. And what it is kind of a model of a particular concept or notion within our application. We generally represent these generally become tables as we go along and turn this into a physical representation and start storing data in it. So each one of these entities / entity types will turn into at least one table. Now, within each entity is some number of attributes. So each one of those items, customer ID, customer first name, customer last name, those are all attributes. Those are facts about the entity that we want to keep track of for the purposes of our application. Now, there may be other facts about that particular entity that exist, but they're just not important for our particular application. So if we take this to a table type view, just to kind of show you how this transfers over, we have this would be entity type turned into a table. We have customer ID, cust first name, cust last name, cust street address, cust city, and so on and so forth. And then within the table, each one of the records holds data for each one of the columns. Like here is the cust ID 1001 for Gomez, Adams, and then his address, and so on and so forth. Each one of the rows is unique. That's what we use these IDs for. They provide us with a form of integrity that says that each one of these rows is uniquely addressable. We can create a set description when we get into SQL that asks for a specific record by saying where that column name is equal to a particular value. We also use these in order to connect related tables, and I'll show you that in just a few minutes. All right. So, but this is basically the physical representation of an entity type with some data in it. Now, entity types hold data about one kind of thing, and only one kind of thing. This has a couple of really good properties by keeping it to just one particular theme or one particular concept. One is clarity. If you start putting in sort of associated or related attributes, it becomes kind of unclear as to what exactly that entity type is about, and then when we try to make a table out of it, then we get confused about what the table is about. One of the problems I run into when people call me up and say, help me, Dr. Barnett, we can't get out our data, we can't use it. And I said, well, what are you storing then? Well, we're storing it all in a spreadsheet. I said, well, you need to start over. All right. One of the problems with storing data in spreadsheets is that you end up mixing all these concepts together. It really makes a mess. All right. So we want one entity or entity type with one theme. Now, you may ask yourself, well, then how do I link it to other related themes? Because, in this case, we have customers placing orders. How do I get the orders together? Well, we do that through relationships. Another good property of keeping these distinct is that your design is inherently stable. Again, it gets very confusing if you try to mix themes into one table. Now, we connect our multiple entities via relationships. They're a connection between the two entity types. All right, so it expresses some sort of linkage about how the data is associated together. It can also be used to express business rules, like in order to be a customer, you must have placed an order, something like that. So in this case, we have this Microsoft specific notation of a line. All of the relationships are generally expressed with some sort of line between two entity types. And in the related table, we also generally reproduce that primary key, and that helps us keep these together. So we'll go through and read a couple of relationships so you can kind of see how that works. So for any given or any one of the customers, okay, so one record of customers can have some number. That's just this is an infinity sign here on this access modeling notation. Can have some number, basically many orders. So that's a good thing. We want customers to place many orders with us. Now, these relationships always go two ways. So these going back, any one order in orders, it can be related to only one customer. And that makes sense. If you start having multiple customers associated with an order, things get out of hand. You don't know who to bill it to. All right? So this makes sense. Just like if you were on Amazon and placing an order on your Amazon account, or if you go into Walmart and you buy something, that little sales ticket, that's basically an order with, some number of things that you bought on it. All right? So you, the customer, and all of your orders. Each one of those orders belongs to just one customer at a time. Now, we can also have multiple relationships, or an entity type or entity can be related to multiple things. They can even be related to the same thing for multiple reasons. Here's an example of an additional relationship to employees. Maybe this is the salesperson that covered the order. So any one of the employees can relate to some number, many orders. So any given employee can relate to many. That's that up sideways, or I guess it's the infinity symbol. I was going to say sideways 8, but it's the infinity symbol. All right. So one employee or the employees to many orders, and any one of the orders is going to relate to only one, hence the dastardly clever one right there, of the employees. And that's basically how we read that. That means that if I want to find out the employees, all the orders that any given employee or all of my employees, all their orders, I can link these tables together, and I can get a listing of all the orders for any given employee. I can get a list of all the orders for any given customer. If there's no link there, then I can't make an association. There's no way to connect them unless there's that relationship. So if you start thinking about pulling things out of multiple tables to create a much larger view of the data, you have to be able to draw this path of relationships to go out and get all this data. So here we have the customer table. We saw that before. And then we have a layout of the order table with values put in for several of its records. Here's my shared column, so that every row here in orders is related to one of these customers. So order number, here's an ID. So order 100,000 on this date and went out this date is linked to Gomez Adams. Why? Because 1001, 1001. Order number 100001, or we'll call it 100,001, is linked to Hannibal Lecter. Why? Because Hannibal's customer ID is right here in this linking column. And apparently Hannibal's placed a couple of orders with us because there he has another one. So for wherever there's a match, that means that this record is related to this customer. And that's how the one-to-many relationship works. And that's really your most common relationship in the relational database environment. So let's take a look at the data model. This is a model that I have some of my students working on in a class writing queries. So we have customers, orders. So customers can have many orders. An order is associated with one customer. An order has many order detail lines. So these are like all the books several books that you buy on Amazon or the multiple grocery item that you buy at the Walmart. And each one of these detail lines is for a product. Now notice we're coming together here. We're not just continuing in this 1 to infinity thing. So the products has all the product information. And so order details basically links what the order was, which takes it back to the customer and captures information about the order itself. And it talks about the individual product that was bought. So the product number, if I want any more detail about the product, I have this connection here that I can go back and I can get all that detail that I want. And then it has information about the particular detail line of the transaction, like what the price was quoted for that particular product, how many was ordered of that particular product. If we look down here at products, we can see the number, a name, a description, a retail price, how many we have on hand, and what category it is. Here we have kind of like a category lookup table that shows what our different categories are. We have vendors, product vendors, and products. In this particular business case, and this is not a particularly weird situation, we have multiple vendors for each of our products. So a product is provided by many vendors, and a vendor provides many products. Well, the way we generally break that down in the relational database environment is we have one of these little, they're called an associative entity type, but really what it does, it captures this web of association. So for every vendor can be related to multiple product vendors, and every product can be related to multiple product vendors. So each record here essentially expresses a particular vendor providing a particular product, how much they charge us for it, and how long it takes to deliver, in case we're going to compute something like an EOQ quantity for one of our inventory models. All right. So if I want to find, I can't really find a specific vendor for a specific product, but I can find a group of vendors that support a particular product. And I can see what products any given vendor has. Why? Because I can draw this map across these different relationships to make that connection. Okay? And so that's basically it. Now, this is just a small model. If you're just starting out, it might be kind of a little on the big side, but it's really just a small model. But anything more than that, it's just really just a matter of scale. It all works the same way. Now, sometimes we don't really need to see all of the native data that's in a particular table. And really, when we write queries, we can use multiple different kinds of sources for our queries. We can have it coming out of tables, we can have it coming out of a snapshot, or we can have it coming out of a thing called a view. And what a view does is allows us to do things like safeguard data. You may have all sorts of data in a table, like an employee table might have what they get paid. Well, not everybody needs to see what any given employee makes. So we can give access to these views, which only show the data elements that we want to show. Sometimes we have just way too many columns. Most database management systems, you can have, I think Oracle, you can have 1,000+ columns in a table. You sure don't want to see all of that for any given application. So we can create subsets of that. And sometimes we also need to see calculated data. The data as it's natively stored is good for the stability of the system. It's good for our transaction processing system, but it doesn't help us out a lot as managers trying to make decisions and write queries. So let's say we needed order totals instead of just a bunch of detail lines. Or let's say we needed to find average amounts. So we have kind of a sticky problem with this data model that we've been using. So we can see here that a wholesale price is linked to a vendor and product combination. It's not linked to a specific product. All right. So retail price is what we sell the product for. However, each of our vendors charges us a different wholesale price. Well, if we're trying to find, some sort of approximation of, what our some kind of projected profit is, what we have times the retail price, we can't get a solid number for wholesale price. So one of the things that we can do is we can come up with a surrogate number for that, or surrogate representation for that, some sort of aggregate, like an average or a mean for wholesale price. Now, that can get a little sticky, trying to write that into a query all by itself. But one of the things I can do is I can just create a view that does that for me, and then I can just use that view. What a view is essentially it's a virtual table. It doesn't really exist. It's based on a definition, not on a structure. And we build it up by defining a query. Now, in the data model that I have for my students in this particular problem, I have a series of pre-configured views. And it's probably not outside the realm of possibility, and it's probably more likely that what you'll be working on as a manager is a bunch of views and not a bunch of native tables. So in this particular model, I have all of my views. They all start off with SO underscore and then a name that kind of gives you a sense about what it's for. So here's like average wholesale prices. So what this view is based on a query that goes and gets the average wholesale price for each one of our products. This one gets the average quoted price out of order details for each one of our products. And then this SO underscore order totals goes out and gets the, this is probably not the correct column name in the model that's on the server, but basically this gets the average total for each order. So an order total is essentially the sum of what you bought, how much you bought something for times how many you bought, and then you add all those up, and that's the order total. So that's what this particular view does. Now, these aren't generally shown with relationships. I don't know, you might work for a company where they are. I have a hard time conceptualizing them being related to anything because they're made up of queries that take things from all over and bring them together. So I don't think that they're generally shown are related to anything. And that might be more than you wanted to know about them, but now you know it. All right. Well, that's it. If you have any questions or comments, if you're in a class doing this, you can use the discussion forum for class, or you can hit me up on Twitter at the Dr. Barnett. Okay. Remember to thumbs up or heart or whatever it is this particular video site does, high five, or who knows. Do that if you would like to subscribe to see other videos. If you found this particularly useful, you can subscribe to this whether or not you're in class or not. I do these all the time. And feel free to use the comment section below. I think Vimeo and YouTube all have comments, and yes, I'm making the little pointing down below action with my hands even though I'm not on camera. So yes, that's weird. Okay, so I hope that you found this useful. If you did, go out there and do something interesting with that data. Until next time.